Welcome to DevOps Days Medellín. This is my first time here. We're going to have this virtual event today and tomorrow. It's going to be on site, I think. Welcome, first of all. Thank you to our sponsors for this event, and the participation of the sponsors is always important for us, and we thank them a lot. My name is David Caballero. I work for W2T as a partnership with WWT in the US. I love to drink some good coffee, no sugar. I watch movies all the time, and I'm always reading some book. You can find me on LinkedIn or email me directly. It doesn't matter. I will answer for sure. I promise you that. And in the right side, you can get the QR code of that information. My topic today is FluxCD. Basically, I'm going to try to explain how GitOps pull reconciliation model works. GitOps is basically one of the best standards nowadays, especially for companies that use Kubernetes. So I'm going to try to bring a little bit more of the pull reconciliation model to Colombia. The agenda for today is what is GitOps, a little bit of the benefits, the reconciliation model, the components for the GitOps toolkit, how to do all these kind of things, and a short demo. So it's going to be lightning fast presentation, like 25 minutes, and then a demo of 10 minutes more or less. I know it's 45 minutes, but I'm trying to show you the demo faster than a lot of theory about it. So everybody knows what is GitOps, or at least have a visibility of what GitOps is nowadays. So GitOps is basically an operational framework. Yes, another framework. But in this case, this one is using DevOps best practices and apply those best practices for software development lifecycle to the infrastructure automation as well. In short, the combination of infrastructure as code, including configuration management, merge requests or pull requests, and CI/CD systems, all those systems combined is what make GitOps a framework. Now, in this framework, we're going to have, for Kubernetes, we're going to have two main cycles. And the first cycle is something that we are a little bit familiar with. It's just continuous integration cycle. So we develop the application, we build the application, we push that application to the Git repository. And from the Git repository, we deploy that application to Kubernetes. It could be a deployment, it could be a stateful set, it could be, I don't know, a daemon set, whatever. Then we monitor that application, and then we go back to Git. Git, in the GitOps scenario, in the GitOps framework, Git is the source of truth, not only for the application, but also for the configuration and the state of the system. And it always push to get the desired state of the system. Now, GitOps works with a technique that we are familiar with, which is a diff, right? So we all the time diff between files, between states, or between the code itself. So GitOps uses the same diff strategy to get the desired state of the system into the Kubernetes cluster. Basically, the intention is that every operation is handled by a commit, that every operation can be pulled through a request or through a merge request or through a pull request itself, and apply all of that for each environment that we have. One of the benefits that GitOps provides is the version deployments and the change history. Everything in your cluster is going to be inside a Git repository. And only by committing or by creating pull requests or merge requests, the users are going to be able to update those deployments or those stateful sets and so on, right? Even Kubernetes objects as well. The second benefit that I see is the rollbacks. So the rollbacks become something simple. Basically, by Git actions, Git revert, or Git reset, you can go back to a previous state of your deployments. And it helps you to always store the state of that system or the state of such service in the long run. So basically, you can always roll back to very, very earlier versions of your code or whatever version you need as it is in Git. Another benefit that you have is out-of-the-box access control. Basically, using the Git system, you can either if it is GitLab, GitHub, Bitbucket, Code Commit, or whatever, you are going to be able to control the access of the users and even use the code owners file per path to approve or not approve changes from the specific users, and also apply specific approval rules over those code owners files as well. Another benefit is the policies for deployment. Basically, you can apply policies or approval rules for merge requests and pull requests, and then you can filter who can approve something. Also, you can lint the configuration. This is a different linting than what you do when you're developing an application. This is linting more focused on YAML syntaxes. And you can also do checkoff. Checkoff is basically a tool, it's an analysis tool for configuration, especially for infrastructure as code, and especially for Kubernetes. So you can apply that over the Git system and scan your configuration to certain compliance and to get certain analysis of what your code is good or not. Now, everybody is familiar with, or is commonly familiar with the reconciliation model that is pushing, right? So basically Argo CD, Jenkins, or many other CI/CD tools out there are going to push configuration and apply configuration over the Kubernetes cluster. So in that way, the build system is going to need access to the Kubernetes cluster in order to do such actions. But that's not such a good approach, because if somebody gets into the build system and is able to impersonate some administrator access to the cluster, you're going to have a very bad security issue there. So in the pull approach, what we are going to do is we're going to install something in the Kubernetes cluster. Let's call it controllers. And with those controllers, we're going to clone the Git repo and apply whatever changes we need over the cluster. Now, in that scenario, the build system doesn't need access to the Kubernetes cluster. Then you're going to have a very kind of a zero trust access control over your Kubernetes cluster. In the pros and cons, we have push. One of the push pros is the security build system. The security is going to be granted by the build system. That could be good or bad depending on the system you use. It's easy to deploy because basically you push whatever you have into the cluster. It's easy to manage the secrets because mostly all of these build system has somehow to handle every secret. It's not bound to any specific tool. You don't really need a build system to push changes over a Kubernetes cluster. Perhaps you only need kubectl and you're done. The container updates by the build CI/CD system are a little bit easier to achieve, a little bit easier to do upgrades over the containers. Now, in the pull approach, one of the pros of the pull approach is no access to the cluster whatsoever. So basically, you are zero trust level there. You can use Helm release controllers to deploy Helm releases. The updates and registries, updating registries and scanning the registries becomes easier. Basically, the controllers allows you to get a container registry, scan, and get the tags, and sort those tags, and then you deploy based on that sorting. Customization for div repos, customization for the path, customizations for the namespaces, and those customizations can be the baseline for approval rules. In the GitOps pull approach, you're going to have lightweight tools. Lightweight tools, very, very easy to install, easy to handle secrets. In this case, Flux CD supports subs native, so you can handle your secrets very easily. There is no dependency with the CD system, so basically you can migrate your pipelines to Azure DevOps, to GitLab, to GitHub, to GitHub, to whatever Git system, and it's not going to change much for the deployment itself and for the GitOps approach itself. No more manual changes. You don't need to apply kubectl changes anymore. Basically, every change is passed through the controllers, so you don't need to kubectl. Well, for those who likes kubectl like me, it's going to be like, oh, yeah, but that's what it is. Now you can also base your pull approach into push tags and release. So basically, every time you push a tag to a Docker image container up to registry, you're going to get a deployment or a release. Now, in the not so good side, the cons for the push approach, we have the cluster credentials are inside the build system. That's what I mean when you have some vulnerabilities on your build system. It's going to be a bad thing to have also the credentials of the cluster inside of the build system. Updating deployments is easier with a pool, but that could also be bad, because if it is too easy to change something on your deployment, it will be easy as well to introduce some malicious code or malicious application inside the cluster. Now, it's strongly coupled to the CD system. That means the pipelines are not going to be easy to migrate in the push approach, because you're going to be tied to the pipeline or the setup of the pipeline of those CD build systems. Now, in the pull approach, managing secrets could be a little bit challenging, especially for the Helm charts, but it can be done with subs very easily as well. It is a little bit harder to implement external tools because the controllers are somehow very restrictive. So with the idea to have a little bit more security, it's harder to integrate the external tools with the controllers of FluxCD, for example. And the last con for pool approach is GitOps toolkit, or GOT, is and understanding the components and how the controllers interact between each other can be difficult to learn. It might take a little bit of time. Now, for the GitOps toolkit components, we have, we have source controller, we have customized controller, we have Helm controller, notification controller, and finally, image reflector and automation controllers. In the source controller, what we're going to do is we're going to get information from the Git repositories, Helm repositories for charts and S3 buckets. And then those components are going to be passed through the Kubernetes API. And if the Kubernetes API is going to have these CRDs, which are custom resource definitions in Kubernetes, one for the Git repository, another one for the Helm repository, and for buckets. And all of those are CRDs from Flux. Then the Kubernetes API is going to allow or present those resources to the consumers, in this case, Flux. And then from those objects, it's going to create specific artifacts that are going to be consumed by whatever controller we need. In the customized controller, when we are talking about customized, we're talking about the customization controller or customized controller from Flux, not to be confused with the customized overlay. It's a different thing. In the customized controller, we're going to handle the tenants. So you can have multiple tenants. You can have one repo with multiple clusters, and each cluster in a different path. And the configuration for each one of those clusters is going to be synced by a customization. So you can handle with one repo multiple environments inside multiple clusters from one repo. Now, in the Helm controller, basically this one is important for the Helm releases. Now that we are promoting the deployment with Helm releases in the companies nowadays. In this case, what we're going to have is the Helm controller is going to render these Helm releases or these releases, and then it's going to apply those Helm releases as an object in Kubernetes. So you can have another CRD, which is basically three different CRDs, one for the repository, one for the chart, and another one for the Helm release itself. Then with all of those controllers, each controller is going to be reconciling and basically doing some sync, and is going to produce some events. Every time that one of the controllers creates an event, you can push that event to the notification controller. And then from the notification controller, you can integrate communication tools or other systems like, I don't know, Slack, Teams, Discord, or even webhooks, and so on. There is a bunch of things that you can connect to the notification controller. Now, the last controller, and I think this one is the important one today, is the image reflector and automation controller. Now, those two controllers works side by side. The first one, the image reflector, basically is going to be fetching tags out of a Docker registry, and then from that Docker registry is going to list those tags, and it's going to present those tags based on the image repository that you set up inside the cluster. And then the image policy is going to take those tags and it's going to push those tags and present those tags against the image automation and against Kubernetes API. And then from then, the image automation controller is going to pick up those tags and apply those tags over the cluster and over the Git repository. And this is the sequence diagram of what I just explained. So basically, we have a persona, and this persona could be a system, could be a person, could be a group of people. And then basically, what you do is you push with Docker, you push a few tags. Then the tags goes to the image repository. From the image repository, those tags are basically being read all the time by the image reflector controller in intervals. Usually the interval by default is 1 minute, but you can set up whatever interval you want. Now, the image reflector controller listing those tags is going to match the tags with the policy, and if it finds a difference, it's going to update the status to the Kubernetes API server. So now we're using Kubernetes API server to notify this, and then from there, the Kubernetes API server is going to notify about the new tags to the automation controller, and the automation controller is going to clone the repo. It's going to patch the manifest within the controller, and then it's going to push the change to the Git repository. So you have updated the Git repository, the cluster, and then you update the status of the deployment in the cluster finally. And in that moment is when you apply the changes over the Kubernetes cluster, and that's when you deploy your new version of your service. Basically, when all of that happens, you emit events, and you send those events to the notification controller, and the notification controller is going to send those notifications back to the persona or to the system that receives those changes. That's pretty much what it is. Now, the workflow is quite simple if you think about it. So you have one user. The user works in a Git repository. This Git repository has a CI job that builds the image and then push the image to a container registry. Then from the container registry, Flux detects those tags. And then if the tag is staging dash something, it's going to deploy that in a staging. If the tag is prod dash something or production dash something, or whatever match you have in the policy, it's going to deploy to production. That's pretty much what it is. And now time for the demo. And we are on time, I think. I tried to be as simple as possible. I think I failed in that part because it has many things in the diagram. I promise I build better diagrams. But in this case, what we have here is we're going to run basically over a GitLab repository. And from that GitLab repository, we're going to build a Kubernetes cluster inside my machine. Then the Kubernetes cluster is going to be created with kind. Once the Kubernetes cluster is up and running, it's going to apply all the configuration and installing for Flux. And then after that, Flux is going to deploy whatever it has in the Git repository, which is going to be one deployment. It's a very simple deployment, which is DevOps API deployment. And then after the deployment is provisioned, we are going to push a change in the repo only for the application. And then Flux is going to take care of that. It's going to take the tag and it's going to apply the new tag over the cluster. That's what is going to happen in the demo. If you want to fork the repo, if you want to do this same example or run this demo on your local machine, you're going to clone the repo. I suggest you that you fork the repo. Then after you fork, you clone, obviously change your GitLab user. And then the only thing you have to do to install everything is just run make install. Make sure that you add the GitLab token, your personal developer GitLab token, the project ID. That's why you need to use your own project, because the script is going to attach a deploy key to the repo. So that's why you need to do a fork. Now, in Flux, we support two different types of customizations. One customization is the customized toolkit Flux CD, which is the Kubernetes custom resource definition for the customizations. And the customizations are the ones that sync the repository with the cluster. The other kind of customization that is supported is the customized overlay. Basically, the customized overlay is the one that you use for generators and for transformation of Kubernetes resources. So let's see the demo. I want to check first that if you are listening to this or not. So let me go back. We're good. Johnny says yes, I think. Let's take a look then to the demo. So the first thing is that we're going to run is the install. And the first thing that is going to happen is that we are going to create a cluster. Then this cluster is a very lightweight cluster that you can build. It's kind. It's just one command and you get a Kubernetes up and running. Obviously for testing. Do not use that in production, please. Now, after the cluster is created, we can see here on the left side is going to apply the resources for Flux. And on the right side, we're going to see that Flux already had the deployment. Then it has some pods that are basically now pending to be running. And in the left side, we're going to have the commands for everything in the script, right? So the first part is the Flux, the CLI tool is going to allow us to install whatever we want. That's what we call the God components. Then we create basically the source, which is the Git repository. We also create that source with Flux CLI. And then we create a secret. The secret is basically an RSA key in order to Flux to be able to clone the repo. And then after that key and that secret is created, we are going to push the public key to our GitLab repository. And we're going to add that key as a deploy key so that Flux can basically clone, pull, push the repository within the cluster. Now, the other part of this is create the customization. The customization is the one that is going to be responsible to synchronize whatever we have in the repo against the cluster, right? So in this case, we have a path here, clusters numprod, and from whatever is in that path is going to be applied over the Kubernetes cluster we just created. The last part that we have here is the image repository, the image policy, and the image update automation policy, which are the components to update the deployment itself. Not to install Flux, but to update the deployment. Now we can see the deployment was applied. Nothing in the scripts applied this deployment. So basically, Flux applied the deployment from the repo. We can check which tag is using. And in this case, we have the F79. That's the SHA I added there. And we can confirm that in GitLab, that's the last one. So go back. And now what we're going to do is that we're going to make the change of the application to reflect the process to update and deployment based on the tags using Flux CD. So Simon is just a friend who was reviewing this presentation with me before today. So now after we do the change, we're going to confirm the service is running first, and we're going to get a response from the service. Basically, the response just a curl request. We get the service, obviously, to get the port. And then we get the IP of the node because we're using a node port service. And then with that, we can build our curl request. There you go. We have an API up and running. This is the older version. Now we're going to push the change to the repo. And after we push the change to the repo, we're going to see how Flux picks up the tag on its own and apply the tag over the deployment. So now you can see the pipeline pick up the change from the commit. is building our image. Yes, it's a pipeline with one job. Yes, I am that simple. I don't like the complex pipelines with 8 hours. I prefer pipelines below 15 minutes or less. So yeah, one job is good enough for this substrate, at least, or maybe more. You can add more things to that one job. Yeah, why not? Now it takes around 50 or 40 seconds to build the image, mostly 50 seconds. In this case, we just wait a little bit. Now that we have the tag push and the job completed, we can go back to the cluster and we can check the deployment. It's going to take, the customization is running with 1 minute. So it's going to take around 1 minute to synchronize the customization with the cluster. And we can see that change. We can verify that. On the right side, we have the customization watch, and we can see the commit is 09 dB. So we can take a look at the GitLab repo and compare that when it's synced. You're going to see that the customization commit on the right is going to change, and you're going to see that we're going to have a new pod on the left side as well. It takes a second. This is still the same pod. 09 dB is the last commit that we have here for the tag. And 53C is the commit for the repo. So 53C already sync on the right side. So the customization was successfully applied. And then we can see the pod. We have a new pod now. The pod is just 25 seconds ago. And then we can get the image tag of this pod, and we can compare that with the pipeline. As you can see, it's 09 dB. So we can go back to GitLab and confirm that. And there you go, 09 dB, which is the tag that we were looking for. And now for the last part of the trick, you're going to see the deployment itself, and you're going to see that Flux also updated the deployment in the Git repo. So in the top, you can see it was Flux who authored this commit, and you can see how it was applied over the cluster, and you can see the Flux image policy annotation. This is not a comment. This is how Flux does the image annotation. And we check our change, and we see the service is updated and up and running. Go back. All good. We go back to the presentation here. Let me open up again. And how the customization looks like once it is applied. So in the left side, we have how the customization looks like. And we can see in the spec of this customization of this Kubernetes object, we can see that we are using the provider for subs. In case we need secrets, we can use subs for that. We can also see the path in the GitLab repo where we're going to sync against the Kubernetes cluster. We see the configuration, and we also see the source. The source for us is going to be the Git repository object, and the Git repository object is another object that Flux provides where we set up the GitOps Labs repo in this case. Now, on the right side, we have a possibility to suspend the customization. Let's say sometimes you need to fix something, you need to, I don't know, whatever you need to do. So you can suspend the customization for a while, and then you can resume the customization as well. I forgot to change the suspend to resume, obviously, but it's here, just change to resume. The reconciliation is basically to force the customization to do the reconciliation right away, because, I don't know, you don't want to wait for a minute. And if you don't want to wait for 1 minute, then you can push it to work faster, right? So who wants to wait for a minute nowadays? Now, this is the image, how the image repository looks like and how the image policy looks like. Basically, on the left side, we have the image repository, and the image repository is just the configuration to where the hell whatever is after, right? And we can sort that timestamp and apply that timestamp as the source of the order how you're going to deploy those images. In this case, we're using alphabetical order and is ascending order. These are the references for those who wants to read a little bit about this. There is also a Linux Foundation training for GitOps. I recommend that you take this one. And there is also a very good book, GitOps Cookbook. It's a new book, but it's pretty good. It's pretty decent. And muchas gracias. That's it. And a special thanks to Simon Davison for his mentoring and review of this talk. He's someone I appreciate a lot. Thank you, everybody, for participating in this talk. And I hope you have learned something new today from this talk. If you want the slides, just scan and get the PDF with the slides. If somebody have any questions, I'm happy to answer. Pueden preguntar en español también, no hay problema. Hello.
Vale. No sé si hay alguna pregunta en el chat.
Creo que quieren el QR.
Sí.
Ahí está el QR. Creo que lo logré en tiempo, ¿cierto? ¿O me pasé? No.
Sí. Sí, sí, todavía tenemos un tiempito por si de pronto hay alguna otra duda o se desea explicar algo más. No sé.
Si quieren ver algo del clúster en vivo, no hay ningún problema. No sé qué quieren ver.
Vale. David, de verdad, muchas gracias. Esto, excelente.
Hey, con mucho gusto. Muchas gracias.
Listo. Hasta luego.
Chaito.